Hi, everybody. Mr. Rubo here. And today we are talking topic 210, inverses of exponential functions. So we're going to continue with logs. So we have the general form of a log here. So it's f of x equals a log base b of x, where b has to be positive. You can't have a base that's not positive. And you also can't have a base of 1. Now, there's a typo in our notes, which is that a cannot equal 1. That's not true. A cannot equal 0. So make sure you fix that. And yeah, we'll have it there. If there's a future one where we've made the fix, then you don't have to worry about it. It should say 0 there. All right. So we have, because exponential functions and logarithmic functions are inverses of each other, we would expect the characteristics of the input-output values of an exponential function to become the characteristics of the output-input values of a log. So you'll notice we switch the x and the y. We switch the input and the output. So here, for recall, for exponential functions over equal with input value intervals, the output values change multiplicatively. So in other words, hey, we're going up by 2 here. Well, when you look at the multiplication or the output, times 2 times 2 times 2. Okay, so yeah, the input values are changing additively, meaning equally spaced, right? So they're going up by 2s, while the output values are changing multiplicatively. Meaning they're multiplying by 2 each time. It doesn't have to be the same number. It just happened to be the case here where we're adding 2 and multiplying by 2, but it could be adding 1, multiplying by 3. It could be anything like that. But this is indicative of an exponential. This tells us it's an exponential function. Okay. For logs, though, we're going to reverse those properties. So in other words, this table shows us a log. So here we're going to see that, 2 to 4, 4 to 8, 8 to 16, that's times 2. Well, now my y's, though, are adding. And again, same number, but it didn't have to be, right? So you'll notice that the input now are changing multiplicatively, while the outputs are changing additively. So in other words, the outputs are equally spaced where the inputs are multiplied. This is indicative of a log or logarithmic function. Okay, so let's do some examples here. We're just going to do the first 3, and we're just literally determining is this a log, is this an exponential, or is this neither of those two things? So right away, we look at your x's. I'm adding 1 every time, so log is out. Okay, and you'll notice, I am multiplying by something. We're getting smaller, so it's going to be by a fraction, so it's multiplied by a half. So as soon as you see that, we know this is exponential, and I'll give you the nice handwriting or nice typing, as opposed to exponential, and our reason would be because input changes additively while output changes multiplicatively, or you could use the word proportionally. We've used that before. So either one of those is your best. All right. Just explanation here. Okay. So actually, let me just do that so we can see it better. Okay. So now let's look at B. Do the same thing. So we're going to look, and you want to look, okay, at the inputs first. That's where I'm always going to look first. And, well, that's times 3, that's times 3, and that's times 3, right? You can look at the addition, but you can clearly see 30 to 90 is much different than 10 to 30. And then here, we're adding 10 each time. So right there, we've figured out, okay, it's logarithmic because input changes. Again, you could either use the word multiplicatively, or you could say proportionally, while output changes additively. Okay, and spelling doesn't count, so don't worry. All right, so then let's see this last example here. We have, we'll look at the x's here. Well, this one is times 10 times 10 again, times 10 again, right? We're really just adding another 0. But then here we're also multiplying by a value. So at this point, we would say this is neither, because input and output values change multiplicatively, which is not the case for either. Sorry, I can't remember how to spell things. It's not the case for either log or exponential. So there's kind of a case where, hey, it's neither. It'd be the same idea if they were both addition, right? If it was plus 5, plus 5, plus 5, and plus 2, plus 2, plus 2, that's not exponential or log. All right, thanks for watching. Have a good day.